Again, we need to encourage our patients to consume an organic diet for multiple reasons. One of which is that, as you can see here, common pesticides are linked to antibiotic resistance. Some pesticides, especially the herbicide glyphosate, as I mentioned previously, function as antibiotics. I've actually read studies where they test for the presence of glyphosate by determining how much of a given sample can kill off the good bacteria that we'd normally find in our guts. So glyphosate very clearly functions as an antibiotic. And in this article from 2015, what was reported is, quote, people exposed to herbicides require more antibiotics to kill bacteria, according to new research published in a very reputable peer-reviewed journal, MBio. Here's the article to which I've alluded a few times now. Pesticides, such as glyphosate, need to be avoided. Let's look at a few details that I've highlighted from this article. Distribution of glyphosate in chicken organs and its reduction by humic acid supplementation. Toward the end of their abstract, the authors state, this enlightenment from their own research will help to overcome the negative effect of glyphosate residues on the gastrointestinal microbiota and thereby protect consumers from glyphosate residues in chicken meat. And you'll see also that the authors document the antibiotic effect of glyphosate to be active against Enterococcus, Bacillus, and Bifidobacterium. The authors state a reduction of beneficial bacteria in the gastrointestinal tract by ingestion of glyphosate could disturb the normal gut bacterial community. The authors go on to state the toxicity of glyphosate to the most prevalent Enterococcus species could be a significant predisposing factor that is associated with the increase in Clostridium botulinum mediated diseases by suppressing the antagonistic effect of these bacteria on Clostridia. So my summary of this is to state the obvious, and that is that glyphosate is commonly found in so-called conventionally grown foods, non-organic foods. Glyphosate is commonly found in foods due to failure of government regulation. Glyphosate preferentially kills good bacteria while sparing pathogens. I think we have plenty of clarity these days that glyphosate is found in many processed foods, such as children's cereal, for example. Therefore, because glyphosate is in the food supply, we also know that it's in the water and the air. No surprise that we're finding glyphosate in animals, we're finding glyphosate in humans, and newer research has shown that glyphosate can actually stimulate breast cancer growth via stimulation of estrogen receptors. Previous research showed that glyphosate is cytotoxic and induces DNA damage, as you can see here from Archives Toxicology 2012. The authors state, since we found genotoxic effects after short exposure to concentrations that correspond to a 450-fold dilution of spraying used in agriculture, our findings indicate that inhalation of glyphosate may cause DNA damage in exposed individuals. Now let's move on from the diet and talk about other components of an overall nutrition strategy to support eubiosis and treat and protect against dysbiosis. Vitamin D also has a role in gut maintenance and gut health. Vitamin D, of course, has many anti-inflammatory and immunomodulating properties. Vitamin D promotes immunotolerance. It's also immunosupportive, meaning that it supports immune defenses. And vitamin D also appears to help maintain tight junctions in the gut, per an animal study that was published in approximately 2008. Many of you know I wrote a review article on vitamin D published in 2004 for continuing medical education. This was published in Alternative Therapies in Health and Medicine. More recent research, such as this article published in Medical Hypotheses in September of 2016, has strongly suggested that vitamin D helps to promote eubiosis and that vitamin D deficiency can actually promote a pro-inflammatory dysbiosis. I'll invite you to pause the video and take a read of this information. I'm going to continue to move forward right now. Let's look at this information showing that dietary omega-3 fatty acids also promote eubiosis, and that's one of the ways that omega-3 fatty acids promote anti-inflammation. What was shown in this study, published in Cell Metabolism, October 2015, is that omega-3 fatty acids beneficially alter the gut microbiome and confer microbe-mediated anti-obesity and anti-diabetic effects. So again, omega-3 fatty acids favorably modify the gut microbiome, and that's part of the way that omega-3 fatty acids induce an anti-inflammatory state. Per this research, omega-3 fatty acids beneficially alter the gut microbiome and confer microbe-mediated anti-obesity and anti-diabetic effects. So previously, for example, we thought that the benefits of omega-3 fatty acids were due to their anti-inflammatory effects systemically, and now what we're seeing is evidence showing that some of the benefits of omega-3 fatty acids are mediated through beneficial alterations in the gut microbiome. Now, you might recall from one of the previous presentations is that I showed you that inflammation and dysbiosis create a vicious cycle. And I'll remind you of the previous diagram that we looked at. Here is a very complex vicious cycle wherein, again, local mucosal inflammation favors the development and maintenance of dysbiosis. That dysbiosis, of course, causes local irritation to be exacerbated. That promotes mucosal damage and leaky gut or leaky mucosal surfaces, which can include in the genitourinary tract or in the orodental cavity. This promotes systemic inflammation, and when that systemic inflammation manifests at the mucosal surface, that again promotes additional dysbiosis. So we definitely see a self-reinforcing and very vicious cycle with regard to inflammatory dysbiosis and systemic inflammation. They each support each other. Dysbiosis promotes inflammation. Inflammation promotes the development and maintenance of inflammatory dysbiosis. And we talked about that concept specifically in the dysbiosis by location presentation on orodental dysbiosis. I'll invite you to pause the video and take a refresher read of this slide if you'd like to. Here's the summary illustration from the article that we looked at previously from Cellular Metabolism, October 2015. And what you see in this diagram is that animals that were fed lard had the induction by that dietary intervention of a pro-inflammatory obesogenic dysbiosis. In contrast to the animals that were fed fish oil, they actually had favorable alterations in their gut microbiome with more lactobacillus, more bifidobacterium, and more Akkermansia, and that helped those animals maintain a lean phenotype, in contrast to the saturated fat diet, which promoted obesity not simply by caloric intake, but rather by diet-induced changes in the microbiome to promote an obesogenic dysbiosis. So the part that I highlighted from this image, mice fed a fish oil diet enriched in polyunsaturated fatty acids are protected from inflammatory obesity, and transfer of microbiota from fish oil fed mice dampens the lard-induced inflammation. So again, the diet changes the microbiome, and the microbiome can either influence a lean phenotype or an obese inflammatory phenotype. New research is also showing that higher levels of exercise can also promote eubiosis, and that's consistent with what I mentioned previously. Physical activity, exercise, helps to reduce inflammation systemically, and it also helps at the local level to promote peristalsis. Moving on now, let's talk about probiotics. Obviously a very important and popular topic in any conversation on the microbiome generally, and certainly on the gut microbiome. So, probiotics are live microorganisms that, when administered in adequate amounts, confer a health benefit on the host. The most recent consensus is that the vast majority of probiotics do not survive in the gut, and that their benefit, although very real, is transient. In other words, they don't populate the gut and become permanent residents. With accurate appreciation of the complexity and the variety of the gut microbiome, we cannot continue to think that probiotic therapy generally, with between 3 and 10 probiotics, for example, is going to completely restore an optimal gut ecosystem. 20 or 15 years ago, when a lot of us started using probiotics clinically, we really didn't have the understanding then that, of course, we have now. We had a very simplistic view of the microbiome. We didn't even have the term microbiome. We just thought that some people have dysbiosis, especially after antibiotic therapy, and we're going to replace the good bacteria that had been killed off. In retrospect, I think we would all agree that that was a very naive view. It was the view of the time. But now we appreciate, more than 3,000 different types of bacteria within the gut, and then we provide probiotic therapy, for example, with or after antibiotic therapy, and we're only giving somewhere between 3 and 10 different species. Well, obviously, that would make no sense for us to think that we're going to completely restore normality after an illness or after antibiotic therapy simply by providing such a small, less than 1% fraction of what had been there previously. So I think we all agree that probiotics are safe, certainly, and that we agree that they are beneficial. What has now reached consensus is that we're all very aware, of course, that probiotics don't survive long term in the gut. Their existence in the gut is transient, short term at best, usually slightly longer than the duration of therapy, a slight residual effect that maybe lasts 1 or 2 weeks, maybe a few months at the most, but that then things tend to return to normal. So one way of addressing that clinically, of course, is just to say that when people are on probiotic therapy and they're receiving benefit, they, of course, need to maintain that treatment just like they would with any treatment. So, beta blockers, other medications aren't looked down upon simply because treatment has to be maintained. So now we appreciate that the same is true for probiotic therapy. To maintain the benefits, people have to continue supplementation, and that, of course, is true for just about all treatments. Of course, probiotics should be used, but within a context of phytochemical and fiber diversity that is the ultimate driver of microbial diversity, as I've already reviewed. Fermented foods add rich diversity and can be used along with a eubiotic diet and probiotic supplementation. Various bacteria are available, of course, most commonly in the families of Bifidobacteria, Lactobacillus, Streptococcus. Notable proprietary products include VSL number 3, that's been widely researched, and it's a popular product among clinicians. VSL number 3 formulations contain between 225 billion up to 900 billion bacteria per serving, and these include Streptococcus, Bifidobacterium, and various types of Lactobacillus. Another popular proprietary product is Culturelle. This is available over the counter. Many grocery stores carry it. It's Lactobacillus rhamnosus GG, or Lactobacillus GG for short, usually about 2.5 to 10 billion colony-forming units. So the way that I would like for us to think about probiotics, of course they are living microorganisms, and we don't want to discount or discredit the